which must be followed to ensure an adequate level of fire protection in buildings accessible to many people, such as airports, big offices or hotels. Engineers often use the compartmentalization approach to divide these big spaces into smaller zones to trap fire inside and give people time to evacuate from the building. More and more partitions are made of glass because glass is transparent, glass looks modern. For those partitions which are required to have a certain level of fire protection, we need a specific glazing. Standard products which are widely used in windows, facades or partition walls of a building usually offer very little fire protection. Let's take, for example, an insulating glass unit. When exposed to fire, the annealed glass breaks fast, falls out piece by piece, opening a way for fire to spread inside or outside the building. There is a sealant which might start burning if the oxygen is present. And similar thing happens with the vacuum insulated glazing. The annealed glass breaks and the vacuum gap loses its insulating property. Another widely used product is laminated glass. This product not only breaks fast but also contributes to the fire spread due to combustion of the interlayer. Fire-resistant glass is a special product designed to withstand high temperatures and prevent the spread of fire. There are three main types of fire-resistant glass. The first one is tempered glass with a low emissivity coating. The commercial name of this glass at AGC is Pyropane. The second one is a group of products made of layers of annealed glass and intumescent gel. And the commercial name of this group of products at AGC is Pyrobel. And the third one is a unit made of tempered glass panes with a gap of a few millimeters filled with an intumescent gel. And the commercial name of this product is Pyrobel T. If we have a coated glass, the coating reflects a part of radiation from fire, which means that the glass won't heat up as fast as the same glass without the coating. At the same time, the tempering process creates pre-stress in glass, and the product can withstand higher differences in temperature. If we speak about products with the intumescent gel, their behavior is more complex. When exposed to high temperature, the intumescent gel undergoes different reactions. First, free water captured inside the gel starts vaporizing, creating big pores and triggering the gel's expansion. Next, the bond water is removed and the layer expands even more, creating a porous opaque foam which stops the heat transfer through the glazing. There are also some smaller reactions coming from other components which continue until the temperature around 600 or 700 Celsius degrees. Above this temperature, the foam starts flowing. Each product needs to obtain a fire-resistant rating. There are different criteria that the glazing must meet, and consequently, there are different classes of fire resistance. For example, Class E refers to a full integrity of the specimen. This means that no flames or hot gas can pass through the specimen to the other side. Class EW, in addition to the integrity criterion, ensures the control of thermal radiation coming from the specimen. And Class EI meets both the integrity criterion and the insulation criterion. The insulation criterion considers that the maximum local temperature measured on the ambient side of the specimen cannot be higher than around 200 Celsius degrees, and the average temperature of the thermocouples in the central area of the glass cannot exceed around 160 Celsius degrees. To verify this criteria and grant a fire-resistant glass, a special test must be performed in a certified laboratory. Fire resistance test also called the standard fire test, is a test that is performed in a big furnace according to dedicated standards. For example, to test glass, we need to follow EN 1363 and EN 1364. According to these standards, we have to assemble a partition wall made of glazing and a frame. This setup is exposed on one side to fire with the gas temperature in the furnace following the ISO curve. During this test, various measurements are performed. For example, to verify the insulation criteria, the temperature evolutions on unexposed side of the assembly are recorded using thermocouples, which are indicated with numbers. These thermocouples are glued in the locations specified by the standard. A small change in the composition of the intumescent gel or in the production process can lead to completely different behavior of the glazing and to different test results. That's why both the composition and the process should be really well optimized to ensure the highest quality of the final product. There are also many possibilities for innovation in fire-resistant glass, starting with different production technologies or finishing with the application of a combination of different gels in the same glazing.